As developers, we're constantly looking for ways to write faster, safer, understandable code. But we often overlook the easy way to achieve this, and that is through value types. So in this video, we're going to cover the benefits of value types and how those benefits are achieved. We're also going to look at when to use them and when you might want to avoid using them. And finally, we're going to look at where the value types exist in our Swift code and how to best utilize them for your code today. But before we get started, please help a fellow developer out and hit those like and subscribe buttons. So how do value types deliver these promised benefits? Well, they do it through three mechanisms. One, they provide complete thread safety. Two, they provide local reasoning. And finally, they are very efficient on small bits of data. So what does this mean? Well, with your thread safety, when you are looking at a value type, you know that you can use it on any thread. It doesn't matter. You know that it doesn't matter whether you're on the main thread or if it's on another thread, because they're not on separate threads. It's always on whatever you're looking at. And that goes into the next benefit, which is local reasoning. See, value types only exist in the scope in which you're looking at them. They don't exist somewhere else. They don't exist on some other function. So when you pass it into a function, whatever you got in that function, or when you have it in a class, whatever you have it, these value types only exist in that scope. And this is great because whenever you look at it, you know you only have to deal with what's right in front of you. You can just say, hey, what's this guy? What's he doing? What's his value? And nothing's going to change that. Nothing's going to affect it anywhere else in your code. So this is super powerful. And finally, they are very efficient on how they are used and copied throughout your system. And so they're fast. You don't have to worry about it being super complex and how it slows down your code. You know it's just going to be done quickly and efficiently. So how are these amazing benefits achieved? Well, it's through the mechanism in which they are shared. Reference types are passed around via reference, via a pointer to their location in memory. But value types are copied whenever they're shared. So you want to use it somewhere here, you're like, hey, I'm going to assign you to this variable. It makes a copy. You want to use it over here, hey, it makes another copy. So everything you have now becomes local to the scope in which you've now shared it. That includes all your different threads. That includes any functions, anything you use it in. It's always a separate copy of whatever the object was. And this is what provides us with these benefits. All right, let's take a look at this in action. So here we have a value type of struct. And it's a superhero. It's got a name and a real name. We've created our superhero, Superman. And let's say somewhere in my program, I decided to create a copy of him. So I'm going to say var copy of Superman is equal to Superman. Okay. Now I'm going to say, okay, you know what? I'm going to update Superman's real name because it's not really Clark Kent, right? That's his Earth name. We're going to call him his real name. So Superman dot real name. And it's not Bruce Wayne, despite what the autocomplete wants to give me. It is Kal-El. All right. Now, what we see here is we've created a copy and we've called the new one or the old one Kal-El, but we want to see what our copy now shows. So we're going to print off print copy of Superman.real name, and we're going to print Superman.real name. All right, let's run this. All right, now that Xcode's got its act together, let's run this. So we see here that our Superman is updated. His name is Kal-El, but our copy still retains the name of the original. It's because when we assign this, it's copied. So anywhere in our code, it's going to be the same thing. Anytime you assign it, it's copied over and you don't have to worry about it. But you might be saying, what about if there's a lot of data? That just seems really inefficient. That is true. It's very inefficient. But a cool thing is that Swift has optimized this, is that when we copied it, it doesn't copy it exactly right then. So it's not copying it on line 13. What really happens, it copies it on write. So when I write to Superman right here, this is when the copy actually happens. Swift's smart enough to go like, oh, whoa, 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 whoa. We're changing this one. Okay, at that point, we want to make sure we're going to figure out who needs this. And basically, it creates the new copy here with Superman. It says, all right, Superman, you're going to get a new copy, and we're going to give you this one. All the originals that were pointing to this version of Superman, you guys keep pointing to him. And that's how it maintains efficiency, even if you had a larger struct item with lots of information in it. Now that we've seen the awesome power of value types, how do we use this in our own code? What do we need to do? Well, that's right here. In Swift, there are 3 types that are value types. We have structs, the most versatile of the 3. You can think of them as kind of like a lightweight class. Then you have enums, a little bit less versatile, great for state management, and still very powerful. And then finally, you have tuples. Tuples are just a lightweight container, a simple way to store things. Now, you might be saying to yourself, that's not a lot to go with. But the truth is, it builds the foundation of Swift. All the foundation types, you have all the number types like ints, uints, doubles, floats, they're all structs. You have the more powerful types like arrays and dictionaries and even strings. Those are also just structs. So you might think, hey, I need to use a class. I need this complex behavior. But in so many cases, we don't need that. We can get so many benefits by limiting ourselves to just using these 3 types. As with anything in software development, you have to know when to use these tools. These are all just tools in our toolkit, and we need to know when to use them when they're proper. A good rule of thumb I like to have is I like to start with the simplest type I can. Start with a tuple, an enum, a struct, and then build it up as needed. So these value types, they're great for state management. They're great for modeling immutable data. These are good tools to use in these instances. And as needed, if we decide that we really need polymorphism or we really need to share an object across multiple contexts, then we expand it. But if we start small, we don't have to worry about all of that overhead, all the mental overhead that goes with shared types. So just to sum that up, it's great to use under a couple of different conditions when you have immutable data and when you want to track state. Not great if you need to share it or if you need inheritance and polymorphism. Final case that you don't really want to use a value type like this is when you have a large set of information that you are writing to in multiple contexts. You don't want to be copying and writing large bits of data. That becomes wasteful. In that case, it might be more useful to use a reference type. Thanks for watching. I hope you found this very informative. Today we covered how value types improve our code by providing us with thread safety and making it easier to reason over our code, as well as speeding it up by providing cheap copying. We've also covered when we should use them, when we shouldn't use them, and also looked into where they exist in the Swift foundations, as well as how we can put them into our own code. So please hit like and subscribe and watch the next one.